Hello, this presentation looks at the determination of sieve analysis tests of sand in a laboratory. I'm Lualaga John Grover presenting. In this video, we are going to look at what is sand, what is meant by sieve analysis test, the test method, test equipments, test procedures, the results, conclusion, and we shall answer some questions. What is sand? Sand is inert particle materials that pass through the sieve of 4.75 millimeter and retain on sieve size 63 micrometer. Sand is widely used in the construction industry, mostly in the manufacture of concrete. 2. Definition of sieve analysis test of sand. This is a test performed on sand to determine the percentage of particle sizes contained within the sand sample. 3. Test method. The test method used is dry sieve analysis. 4. Test equipments. The sieve is the main piece of equipment used in the sieve analysis test. As you see, it has holes or apertures which allow sand particles smaller than the holes to go through, and those larger than the holes to be retained on the sieve. The scoop is used to pick sand particles from one point to the other. The drying oven is used to extract water from sand sample at a temperature of 105 degrees Celsius. The weighing scale or balance is used to get the exact weights of the sand particles. The lid covers sieves such that sand particles are not lost during the sieving process. The receiver collects all the sand particles that go through the sieves. The metal tray is where sand particles are placed while transferring them from one point to another. The hard brush is used to clean sieves that have holes or apertures larger than 1 millimeter. The soft brush is used to clean sieves that have holes or apertures smaller than 1 millimeter. The spade is used to pick large quantities of sand samples. Sieve shaker helps in the sieving process, whereby a set of sieves is secured tight on the sieve shaker, and with supply of electricity, the shaking of the sieves can be done with ease. 5. Test procedures. The procedures followed while carrying out the sieve analysis test include preparing the sand sample. Number 2, arranging the sieves. Number 3, carrying out sieving. And number 4, weighing sand retained on each sieve. Now let us look through one by one. Number 1, preparing the sand sample. The sand sample, about 12 kilograms, is placed on a large metal tray, and a representative sample of about 1.5 kilograms is obtained. The representative sample can be obtained by the quartering method, whereby the sand sample of about 12 kilograms on a metal tray is heaped and divided into 4 approximate equal portions, which form 2 diagonals. One diagonal is retained and another diagonal is discarded. The process is repeated until the sand sample is reduced from 12 kilograms to 1.5 kilograms. When the representative sand sample obtained is not perfectly dry, then it should be placed in the drying oven at a temperature of 105 degrees Celsius for about 16 hours to allow it to dry. The dry sand sample is then left to cool to room temperature, and then the exact 1.2 kilograms or 1,200 grams is weighed using the weighing scale. 5.2. Arranging the sieves. The table shows the sieve sizes to be used while carrying out the sieve analysis test. As you see in the table, we have about 14 sieves. Sieve 10, 6.3, 4.75, 3.35, 2.36, 1.7, 1.18. Those are in millimeter. 825 micrometer, 600 micrometer, 425 micrometer, 300 micrometer, 212 micrometer, 150 micrometer, and 63 micrometer. These are the sieves we are going to use. Now, the sieve sizes will also be indicated on the labels of the sieves, so that when you look at the various sieves, you will be able to read the aperture, and that will be the sieve size. Now, before the sieves are arranged, they are first cleaned such that all sand particles existing in between the holes or apertures are removed. The sieves are arranged in a descending order from top to bottom. That is to say, sieve 10 millimeter should be at the top most sieve, followed by a smaller sieve with smaller holes to the last. And at the bottom, as we see in the table, we have sieve 63 micrometer. The sieve arrangement should ensure that bigger sand particles are retained on the sieves and smaller particles are allowed to go through the sieves. Now, in the middle, you will see that we have what you call the lid, and on top of the sieve 10, and the receiver at the bottom of sieve 63 micrometer. The dry 1,200 grams sand representative sample is placed on the topmost sieve, say sieve 10 millimeter, for our case, and covered with the lid. If a sieve shaker is to be used, the set of sieves is tightly secured on the sieve shaker. The machine is led to shake the sieves containing the sand sample for about 15 minutes. Then, after the shaking process is done, the sand particles retained on each sieve are collected and weighed. If sieving is done by the use of hands, the representative sand sample is placed on a single sieve, starting with one having the larger apertures or the bigger holes, say sieve 10 millimeter. The shaking of the sieves with sand particles is done in a circular motion. The sand particles retained on the sieves are collected and weighed. The sand particles that pass through the sieves are transferred to the next sieve, say sieve 6.3. The process is repeated until all sieves are done. 5.4. Weighing sand retained on each sieve size. All sand particles retained on each sieve are collected and kept separately. Their individual weights of sand retained on each sieve are determined and recorded in a record sheet. Now, what you see is a record sheet. The weights retained on each sieve are recorded. against their respective sieve size, as you see in the table. 6. Let us look at the results. After recording all the weights retained on sieve size, calculations are then made to determine percentage weight retained, that is, as you see, A, B, C, and so on and so forth, cumulative percentage weight retained, X, Y, Z, and cumulative percentage weight passing each sieve size, that is Roman number 1, 2, 3. So we are going to, in this video, we are just going to look to calculate ABC and so on and so forth, and then with the calculations you can be able to fill. Let us look at the calculations. Calculating percentage weight retained in percentages. Percentage weight retained is equal to weight retained on each sieve in grams divided by original sample weight, that is 1,200 grams, times 100%. Now for A is equal to what was retained on our sieve 10 is 0, divided by 1,200 times 100%, which is 0%. For B is 11 divided by 1,200 times 100%, which is 0.92%. For C is equal to 12 divided by 1,200 times 100%, which is 1%. Let us see how to calculate the cumulative percentage weight retained. For X is equal to A, which is equal to 0. For Y is equal to A plus B, which is equal to 0 plus 0.92, which is equal to 0.92%. For Z is equal to A plus B plus C, which is equal to 0 plus 0.92 plus 1, which is equal to 1.92%. Calculating the cumulative percentage passing Roman number 1, 100 minus X, which is equal to 100 minus 0, which is 100%. It means that 100% passed through the first sieve 10. Roman number 2, 100 minus Y, which is equal to 100 minus 0.92, which is 99.1%. And Roman number 3 is 100 minus Z, which is 100 minus 1.92, which is equal to 98.1%. Now, when you look at the table, these are the results which we have been calculating. Now, using the above examples, the table can be filled as seen. Using the values in the table, the grading curve is plotted on the particle size distribution chart, whereby cumulative percentage passing is plotted on the y-axis and against the particle size, which is the sieve size, on the x-axis. Now what are you going to get is the grading curve. This is the shape of our grading curve. In conclusion, depending on the particle sizes existing in the sand sample, different grading curves shapes can be obtained. Like for example, we can see A, B, C. So shape A indicates that the sand particles are uniformly graded. Shape B indicates that the sand particles are well graded. Shape C indicates that the sand particles are gap graded. When you look at the shape of our grading curve, which is the first, and compare it with the different shapes, you will find that the shape of the grading curve we got is similar to the shape of the grading curve B. Hence, our sand sample is well graded. It means that this sand is of good quality and suitable to be used in civil engineering works like manufacturing of concrete. Now let us look at the diagrammatic representation of sand particle arrangements. Now, if the sand sample is well graded, then it will have bigger particles, quite a little bit smaller, and smaller particles. You will find that it has ranges of particles. If the sand is uniformly graded, you may find that it has only one type of sizes. Say the particles are almost same shape. Gap graded, it means that it has bigger particles and very small particles. It has no particles in between. Now let us look at the questions. Try to answer these questions. Question number 1. What test have we looked at? A. Sieve analysis test of coarse aggregate. B. Sieve analysis test of sand. C. Sieve analysis test of cement. D. Sieve analysis test of maize. Question number 2. The following equipments are used in the carrying out of sieve analysis test except oven, A. B. Chair. C. Scoop. D. Fork. E. Teaspoon. Question number 3. The following procedures are followed while carrying out sieve analysis tests of sand except A. Prepare the sand sample. B. Arrange the sieves. C. Place the sieves in the oven. D. Carry out sieving. E. Count the sand particles retained on each sieve. Question number 4. The following image represents which type of sand? A. Gap graded sand. B. Uniformly graded sand. C. Well graded sand. Thank you very much.